Up next, we have Shinran, who's a senior software engineer at Netflix. She's on the personalization data engineering team, building data applications to power ML algorithms and product innovation. Before Netflix, she worked at Confluent and Target as a data engineer. She founded a publication dedicated to data engineering called Data Engineering Things and writes regularly. Welcome.
Yes, thank you for the introduction. Hi everyone, my name is Jiran Weibo and I'm a senior data engineer at Netflix. And today I'll talk to you about how to engineer data for better data quality. And I personally love emojis, so if you see anything in my presentation you love, bring on all the emojis. I love them. So let's get started. And so here's the agenda for today. I'll first tell you a little bit about myself. And for those of you who's not familiar with data engineering, I'll give you a summary of what data engineering is. And since we're going to spend the whole time talking about data quality, I'll talk about why data quality should be the bottom line of any data engineering system, how to define data quality, how to monitor data quality as part of your data system. And at the end, I prepare a sweet summary of the best practice that you can use to ensure high data quality in your data system. So first of all, a little bit about myself. My name is Gina. I know this is a name that's kind of hard to pronounce, but the trick is that the X is pronounced like SH. And I have been working in data engineering for about 6 years now, and then I'm still having a lot of fun, loving it. And I always tell other people that being an data engineer, like I get to solve data puzzles every day, and it's very rewarding. And right now, so I'm a member of personalization data engineering team at Netflix, and my team build various different data systems that feed data into our personalization data algorithms. And I also personally really like writing about data engineering too. I created this publication called Data Engineering Things on Mediums, and then I write blogs every once in a while to share my learnings of what I learn at work. And I hope you check it out later after the presentation. And in my personal life, I'm a dog mom. Here's a picture of me and Foxy. We spend a lot of time together. And also I love pottery. I just learned to do ceramic last year and then absolutely loving it. Actually, this year I just set up a small pottery studio in my garage. And I'm very excited to do more pottery at home. So get to the technical topic. So what is data engineering? And if you search about data engineering online, you might see so many different keywords that you see here. It's about building data pipelines, data plumbers, data cleaning, and the ETL, ELT. And you might learn about batch and streaming and frameworks like Kafka and Spark. But what is data engineering? Like from my perspective, like all of these is all part of data engineering. However, it's only describing data engineering from a specific angle. And here is what data engineering is in my own eyes. So for me, data engineering is all about making data accessible in optimized formats. When I say optimized formats, that means that the data is enriched with business logic and metadata, so it can be easily used to solve business problems. And data is also stored in efficient data schemas and storage system. So if your downstream user are going to process this data further, they can get great performance in their data processing too. And last but not least, the data should be available within the desirable latency, because there are some data you would get more value when you build up a significant amount of history, but also there are data would lose its value as the delay goes up. So you might need to build a data system that runs daily or hourly, or even streaming system that processes the event as it comes in. And most importantly, all the data engineering systems should provide data in high quality. And I believe that is the bottom line of any data engineering system. So why is data quality so important? And the main reason is because the outcome of data engineering system is used to derive data insights, whether it's used to generate some metrics dashboard for executives, or it is used to directly power some product feature, or it's used as input data to your machine learning algorithms. And any data insights can only be as good as the source data. So as you can imagine, if your data engineering system is producing incorrect data, any of the decision made based on those data will be at risk as well. So this stock meme here, I love it, and it perfectly summarizes that why I want to give a 20 minutes presentation today on data quality itself, because I've seen so many data systems in the past, including the one I've built myself, that don't have data quality check. And the data engineers don't even know when the data systems are not running correctly or producing incorrect data. And at the same time, important decisions are being made based on those data. And that is a very dangerous situation that you don't want to be in. So now that we're all on the same page about why data quality is important, let's talk about how to define and measure data quality. Actually, defining data quality is not an easy task at all. So the first and also the most important step before you define data quality is that you have to know your data well. Ask yourself these 3 questions. What does my data represent? How is my data being used by downstream users? And what could possibly go wrong? And for any data engineer to answer those questions, I believe business context is really critical because you have to understand the business problem first before you build your data system, and of course, before you design data quality, for a few reasons. So the business model determines the nature of the data. And for example, how your business work is directly associated with the data that's getting produced. For example, when you think about what is the relation of account and the profile, that was directly impacted by how user can create account and the profile when they use your product. And another example is that business model also determines the traffic pattern that you might observe in your data. Let's take Netflix, for example. If you work for a company who's based on, it's about entertainment like Netflix, then you might have more traffic during holiday and weekend versus on weekdays. However, if you work for a software company who builds software for business uses, then you might have more traffic during weekdays versus on holiday. And also business context help you spot the potential edge cases too. So let's say if you work with playback data on Netflix, and you would think about, hey, how would my data surface edge cases like where the user tried to start a playback but then didn't start? How would you identify those cases in your data, and how do you want to deal with it as part of your system? And because any data engineering system is built at the beginning to solve specific business problem, so in a way, the downstream use cases actually define the expectation of your data. And also that means that the definition of your data quality is only valid for the use cases in mind. I know this might sound kind of conceptual, but let me give you an example. Because the data quality itself is a very subjective matter. It's really depending on how you expect the data to be used and who's using it. So let's take Netflix, for example. Let's say you are building a dimension table that represents Netflix movie, and then you have a category field. For when you talk about category, and it might mean different things when you talk to different departments. It could mean the category that we surface on our product for user to select, to explore movies, or if you're talking about category on the content side, it's a different category when it comes to content production. So let's say if you build this data set for product use cases, then your data quality would be at risk if you start surfacing the production category in your data set. So that is example how data quality is relative to the use cases. So for data engineers, my recommendation is always that if you ever feels like you don't understand your data well, I recommend you always talk to other teams, your business partners, so that you get more business context and understand how the business is associated with your data. So assuming that you have a good understanding, a comprehensive understanding of your data now, it's important to establish some clear expectation for your data first, and also tolerance, because no data is perfect. So for example, the column should only have values and meeting certain criteria. And for example, the membership tab should only be basic or premium. and data should somewhat align with historical value. For example, the number of accounts that you see today should be very close to yesterday. Another thing you could also set is that the data should be somewhat aligned with another data set. Let's say you have a data system that processes input data and then does a approximate one-to-one mapping, then you can expect the output it's relatively aligned with the input as well. And from an SLA perspective, we can expect data to be available within certain latency. Let's say if you have a daily workflow, then you can have the expectation that the daily job should finish before Pacific AM every day. So this is just some of the very basic expectation we would have on data sets, but also depending on the data and the data system, you might want to add more to the list that's more complicated. So now that you have a clear set of expectation of your data, the next step is to compute data quality metrics that help you quantifying the deviation of the actual data from your expectation, and then you can compare the deviation with your tolerance to see whether the data quality is up to your bar. So here are some of the examples. For example, you can compute the percentage of playback events when the membership ID is invalid. Or you can check the number of playback today, assuming today is Thursday, and comparing to previous Thursday average. I really love this example here because it gives you the idea of that how you can kind of incorporate the traffic pattern that you are aware of in your data to your audit so that you can audit on your data quality more effectively. And another example is that you can calculate the percentage of playback events, but only those with membership tab is basic, and compare it to the 7-day average. This is also a great example that how you can add more dimension and breakdown to your data based on your best understanding of the data to ensure that data quality is high. And another from a SLA perspective, you can measure the end-to-end runtime of your job and making sure that it meets the SLA of your downstream user. So, there are so many possible data quality checks you can have in place, and you might be wondering, oh my God, how many is enough? Honestly, there's no right answer. However, my personal rule of thumb is that, with this list of data quality check I have in place, if they all passed, I can confidently say for sure that I know my data is all good. So that is the principle I usually use when I design data quality checks. So next section, monitoring data quality. So this section is important because data quality check isn't a one-time task. Beyond all the unit tests and integration tests you have as part of the development process, you also want to monitor your data quality continuously as part of your data system, so you can keep track of your data quality as your business and data evolve. And this section, I'll talk a little bit more about how exactly we do that. So the methodology of integrating data quality checks in your system is a little bit different for batch and streaming system. So in the batch world, we typically use this pattern called write, audit, and publish. So the first step is that you run your batch job, write the output to a temporary location. Then you run your data audit check against those outputs. If it passed, then you publish those data to the permanent location. And as you can see from the screenshot here, that when the data audit didn't pass, then it would actually send a pager to our on-call, and the on-call will intervene and investigate. If everything is good, then they will manually unblock it, but if it doesn't, they will reach out to other team to investigate further. So that is the write, audit, publish pattern that we typically use for batch pipeline. So in the streaming world, it's a little bit different. For even streaming job, we would typically alert based on some of the real-time metrics we collect from application. It would include some of the job health metrics, for example, the number of jobs that's running, the consumer lag watermark, making sure that the job is making progress, is not left in behind. And also, we also have a lot of custom per event metrics we capture as part of the data processing logic as well. Like, for example, the number of events that filtered in or out, the number of parsing failure we're getting, the number of records with invalid fields, and also the output volume. So those are just some of the simple examples you could do. And another thing I want to mention here is that Because these days is actually really common to write the output of your event streaming job to a table, you can also use the write audit publish pattern on your streaming output as well. But the only difference is that it's the delay that introduced because you are running your audit at the theoretical manner as part of a scheduled batch job. So assuming that you are a responsible data engineer, you know your data well, you also set up all this great data quality check as part of your system. What could possibly go wrong from here? And this is another scenario you could be in, that you have so many data audits that's firing alerts all the time, and some of them may not be reflecting a real issue. So you don't even know which fire is real, which fire isn't. And that puts your team in a lot of on-call burden and also just operational cost as well. And that leads to the next section, the common challenges of maintaining data qualities in production. So one of the common challenges, as I showed in the previous stock meme, is that you might have a lot of data audits that's very noisy, and the noisy one might distract you from the real data quality issue. For example, it might be because that you have too low a threshold, or because that you totally ignore the organic traffic pattern as your data quality. So you're basically alerting based on the organic traffic pattern that's expected. So, the recommendation here is always that, revisit your data audit periodically to see which one need to be tuned so that it can be more accurate and not producing unnecessary noise. Another challenge here is that sometimes data audits don't get updated as you update the business logic as part of your job. Like we talked about before, data quality is relative to the business problem you're solving, so that whenever you update the business logic as part of your system, you should also revisit your data alert so that your data quality check is up to date as well. Next one, that one is also really painful, is that because you don't log enough information as part of your system and also your logging, it's very difficult to troubleshoot failures. So this would actually apply to both batch and streaming world, because a lot of times, we might see a real-time metric saying, oh, hey, we have a spike of parsing failures. However, it doesn't log enough information about the event, the identifier of the event. So it's really hard to go back to troubleshoot what event got dropped for what reason. And similarly for the batch world, a good example is that if you have a Spark job that have 20 filters on the source data, and all the data might get dropped because of that one filter, but it could be really hard for you to figure out which is that filter that is causing the problem. And that is all because of lack of logging or intermediate data you are producing. So just be mindful about what data you should log or intermediate data you should produce, so that it's easier for your on-call and yourself to troubleshoot the issue when it comes. Another common challenge, which is actually a problem that my team deal with a lot, is that a lot of times your data audits fire not because something went wrong within your data system, actually has to do with upstream data changes. So it's very common that in some of the data systems that you build your data system based on some assumption of your source data, and therefore there's certain type of data contract there between you and your source system. However, because when those data contract is not enforced through some programmatic matters, such as integration tests, then it could be broken all the time, and then you catch those issues in your data system instead, and then you have to go back and forth with the upstream team to fix them. So in this case, it is really important that you enforce the data contracts with your upstream through some programmatic methods, so that it's less likely for upstream to introduce unexpected data updates. Another problem that probably applies everywhere is that people come and goes, and then they might not have enough documentation on the data quality check, and you might not know why certain data quality check is there, and when it fails, you don't know what to do. So it's always the best practice to add enough documentation for data quality and why that exists and what to do when that fails. Another one, but this one is very interesting one, because we don't run into this very often, but it's also quite an interesting problem, is that when we build data audits, a lot of the times we would explore the data based on the historical data already available, and then that kind of help us understand the data a little bit better and set some tolerance. However, if you are building a data system for a completely new product, you would have no historical data to refer to, so it could be very difficult to set data quality check and the tolerance you have. And in this case, honestly, I don't have any really good ideas, but I think the best thing you can do is that just to keep a close eye on your new data pipeline and this data getting produced because as part of the new service, and then revisit the data audits maybe after a week or a month after it's released, so that you just have to keep an eye on it. So, another really important thing I want to cover at the end is about data recovery. So, because no data is perfect, so you are going to eventually, have a lot of failed data audits that can tell you, hey, like there's some serious issue with the system, it's producing incorrect data, and what could you do? And sometimes, you might be able to fix it very easily. However, if the data is already produced, and you have to have some backup method to backfill the data to mitigate downstream impact. And then the methodology for data recovery is actually different for batch versus even streaming system. In the batch world, it's pretty much guaranteed that all of your system will be backfillable because usually you're reading from data from a location where the data have really long retention, and then you could just simply rerun your batch job, and then also ask your downstream to rerun, and then you just basically do this override the partition, and then data could be fixed. However, in the streaming world, not all system is by default backfillable. That is mainly because the source of the data usually have very limited retention. In most cases, that is a Kafka topic, and it's very expensive to have very long retention for your Kafka data if your data size is really huge. So there are some options for backfilling streaming job here. I'll just give you guys a quick summary, but I could literally talk about this for an hour if I want to.
Yeah, can we, Shannon, can we wrap this up now? We have people in the next session ready.
Yeah.
So can we
definitely.
wrap?
So there's also options for backfilling, but then my recommendation is that you should always have some backfilling options in mind when the data outage happens. So just a quick summary of the best practice I have in mind for data quality. So first of all, you want to design every data engineering system with data quality in mind. You must know your data and business problem well, and then you want to integrate your data quality metrics and alerts as part of the system. So that means that when they pass, you can rest assured that knowing that now is good, but also when fail, you should have clear action item to follow up with. But last but not least, you should always have a backup plan for data recovery so that when the outage happens, you have a way to mitigate downstream impact. So yeah, sorry for running out of time. That's everything I want to cover for today. So feel free to find me on LinkedIn to connect with me. And if you want to learn more about data engineering, check out the data engineering things on Medium.
Thank you, Shinran. This was wonderful. See you in the next session.
Thank you, everyone.